or actually, yeah, or actually you can wait, in fact, because most of the things that we have discussed yesterday or in our previous class, same is going to be over here. Yeah, so these slides, so one can say that several things may actually be taken from this place, and there are more. So there is a reinforcement learning course by deep mind person, Black. No, that is Silver. I'm sorry. So, Silver. So that's a deep mind person. His name is David Silver. And things are being taken from there as well as from this lecture series. In fact, there is one lecture that's been taken by her about reinforcement learning included in this course. So things have been taken from there. Okay. So oral, you understand that input data will be there, and then we have a reward. So we have an agent, we have an environment, then we have a state, we have selection algorithm by which we can select that at this state what action need to be taken. Depending upon that, reward is going to be there, and algorithm need to be in such a way so that we should understand how to select the best action, and depending upon that you are going to get your output. So here you can see that your raw data is having different classes, and finally your output somehow going to classify them into different classes. So where it states, I mean, one can say that where is deep learning, where supervised and so on. So this is actually a nice pictorial view in which the whole thing if can see as an artificial intelligence.
Sir.
Yes.
Sir,
Yes.
video is coming blur. So
video is not coming.
Yeah, it is coming, but it is coming blur. Text is not visible.
Video is coming blurred.
Yeah. It is not
maybe
focused
for
properly.
this slide, maybe for this slide or also for this.
Yeah, for this it is okay. It is big text, so it is visible.
This is okay. Then it
Yeah.
may be that the font size over here is not very. You don't zoom,
Okay.
Daksh, Ranjit. Because that's okay. Now you can see,
Yes.
right?
Yeah, little bit visible. Okay.
Okay. So if we see this thing as yeah. Yes, if we see this whole thing as artificial intelligence, then machine learning is actually one subset of this. Within that, supervised, unsupervised, and then deep learning. So you can see that there are too many algorithms which can be over here. They may be supervised, unsupervised, but may not be deep learning algorithm. Same with the case of unsupervision. And then reinforcement learning is also a typical different type of thing. So you can see that we have supervised, we can have unsupervised, we can have reinforcement. And then we have deep learning, which is in, having algorithms for deep reinforcement learning, deep supervised algorithm, and deep unsupervised algorithms. So now we are going to start. So anyways, we all know that, and last day we have seen this. I'm not going to elaborate more on it, but just to rephrase that the supervised learning is there, unsupervised learning is there. And we all understand that for the data, we know that what is the X and what's the corresponding label. In the case of supervised learning, we have X, but labels are unknown. And if labels are unknown, then in the absence of the target, several times we wanted to understand that what is the distribution from which this data is coming. In the case of reinforcement learning algorithm, it's a separate paradigm. And this is such a paradigm in which we explore, and agent started to interact. Agent started to interact with the environment. It actually need to understand how to interact in the best possible way with this environment. And initially, when it doesn't know anything, it started to interact naively, but repeatedly after some amount of time, it started to understand first. So after that, it started to actually understand that, okay, what's the best way to really respond to the environment. So it's basically a hit and trial strategy, but we need to somehow manage such a type of hit and trial strategy, need not to be explicitly brute force type of algorithm. So there are very good ways by which they have done that, but basically it need to understand how to behave optimally. Keep on using your pen and pencil, copy, pen, whatever, and if you have any question in between, you can ask. Yeah, so environment is there, agent is there, so numbering is there, environment is there, agent is there, and environment is going to give agent that what is your state, ST. Depending upon that state, agent need to take an action, AT. Depending upon that state and the corresponding action, environment is going to tell you that what is the reward that you have got. And with respect to that reward, with respect to the state and the corresponding action, you got to know that what is the next state. Environment is going to tell you that. So all these things are being written in this detail. Everything will be provided to you. YouTube lecture recording of this, the previous recording, along with all this PDFs and so on. You need to concentrate what we are discussing and keep on writing, because that's going to be more and more important. We have covered all this. So when I say that reinforcement learning, then it's actually being seen and being shown in several ways that this type of problem we just have shown can actually be formulated using a Markov decision process. So Markovian property is one thing, Markov process is second thing, and the third thing is Markovian decision process. So today we are going to see that. By the way, there are two ways by which such problem is actually being solved. One is Q learning, other one is policy gradient. So these are the two broad categories of algorithm. One is Q learning. You understand last day that there is something which is called as Q function. There is something which is called as pi, which is the policy. So if somebody gives me Q function, I can use a greedy policy. Understood? Yes, no, raise your hand. If somebody gives me a Q function, we can use the greedy policy. Understood? No. Yes, Deepali said yes. Okay. Only 2, 3, 4, 5. Okay, fine. So if you give me Q function, I can use the greedy policy. But then Q function is implicitly touching my policy. You all agreed. It's actually an implicit handle over my policy. I'm not really working on policy space. Now suppose that this is a subspace. This is a space in which all policies lie. I choose first policy and check how good it is. Then I can choose the second policy, how it is. Choose the third policy and how it is. In the case of Q function, we are learning Q function. So basically in that Q function space, we are traversing and then using just only the greedy policy. Other way around is that don't worry about this Q function. I'm not really interested in that Q function. I directly work in the space of policy. If you want to work in the space of policy, you need to know how can you differentiate a policy from others, that this policy is good, that policy is bad, which essentially means that policy gradient. Top level, very top level. That's Q learning, this policy gradient. So in the case of Q learning, we optimize or learn this and then use greedy approach as a policy. In the case of policy gradient, we directly optimize over policy. And both of these are two different class of algorithm, class 1 and then we have class 2 algorithm. Two different classes, so many different algorithms. All of them are Q learning. All of them are several different algorithms. They are policy gradient. And then it comes that there are another class of problem. They are being called as actor critic problem, AC, actor critic problem, which so they are utilizing both Q learning as well as policy gradient. So these are the three types of algorithm, and in each type there are multiple algorithms. Keep on updating the previous algorithm one by one, and that is the whole, the thing, algorithms that we need to cover up in our deep learning, this RL course. So we have understood that environment and so on. So everything is being well understood by all of you in our last lecture. Now the point is that how can we train such a system? You have an agent, you have an environment, you have an agent, you have an environment. Agent knows how to, so agent, environment is giving me the state. I am doing something, some action, I'll get a reward, and then I got a new state, and keep on doing, keep on doing, keep on doing. How can we train such a system? So it is actually episodic training. We need to understand what is episodic training. So we have seen 6 steps. What are they? We all understand: agent, got a state, do an action, got a reward, and depending upon the state and the action, got a new state, and keep on doing. So that's actually a cyclic process that keep on doing. That is one step that you have taken. So what you can do is that then you take another step. So it may be that from here you have taken another step. So you are state number 0, you take an action A0, you go to S1, first state, then you take A1, and then you go to S2, and then you take A2, and then you take so on. This is S3, and then A3, and here you got terminated. So you got terminated over there. So you keep on doing this until you got terminated at somewhere. So you start with some initial state. You just think about a game. You are playing a game. Tic-tac-toe, this, that, whatever you can think of. You have some starting state. You take an action, next state, take an action, next state, take an action, next step. How you are taking an action, forget. You are taking random actions. Just take random actions. If you are taking random actions, you are moving. At some point of time, you got terminated. Your game completes. Either you win or you lose. That's okay. But this is one episode. And then you keep on playing and generate huge amount of episodes. And this is going to somehow let my agent understand that if you take these type of steps, it's more likely that you are going to win. If you take other type of steps, it's more likely that you may end up losing. So that is episodic training. Any question? Let us have 1 or 2 questions over here if you have. Episodic.
So how can there be an action associated with the terminated state?
Action associated to
the terminated state. So आपने बोला ना that S3 पे terminate हो गया, तो how is there an A3 there फिर?
S3 पे मैंने कुछ एक्शन लिया जिससे कि मैं टर्मिनेट हो गया. भाई आप एक फाइनल स्टेट पे थी, यहां से ऐसे बॉल गिरने वाला था, यहां, अब आपने आगे बढ़ा दिया तो ये जमीन पे गिर गया, टर्मिनेट हो गया. ठीक है? नो.
ओके सर.
किसी और को? अच्छा, so don't worry about it because we are going to cover things in very detail. So this is just to let you understand things from very top. ठीक है ना? Example, cart pole problem का एक example. Let us see. You have a car. ये क्या है? This one. किस पे चलता था? मैं भूल गया. Yeah, this one. Okay. इधर क्यों नहीं चल रहा? So basically we are having a car over here. Okay. we can apply force in this direction. So right now your car is only going to move in this direction or this direction. So in 1D motion, you have a line like this. So this is actually the vertical. You have a mass angle theta. You need to apply force in such a way so that your this mass need to be vertical as possible most of the time. Otherwise, it's going to be down over this side or that side. That is when you are going to lose the game. Your objective is to balance the port on the top of the movable cart. Your states can be encoded as the angle. You can see this angle. Angular speed, omega, position, horizontal velocity, and so on. Angular speed, other things, please don't ask me. I may actually have completely forget about this, but things like this, which are going to be really the physics behind that, why this pole is moving in a certain direction. What are the things that you think may be required so as to understand the actual state and to make it vertical? So whatever things you feel that can actually be coming into the state, what's the action? Horizontal force that you need to apply in the direction. So basically when I say force is a vector. So you need to tell me that what is the direction in which I need to apply the force and how much amount of force I need to apply. And what's going to be the reward? Reward is going to be +1 each time if the pole is upright. It is just wanted to say that pole is upright, you are getting reward. If it's not upright, you are not getting reward. In order to get more and more rewards, you need to learn how to apply force with respect to the given state vector so that your pole is most of the time upright. Now, Attari game. You all know what is this Attari game, and in fact, this was their first paper. What was that paper's name? I forget. So they have shown that DeepMind have shown that you can use reinforcement learning successfully to play games, and they are the Attari game, Mario, and this and that. If you remember, in which some video screen is there, and within that video screen you are playing games, and they have shown that just by letting an agent play and take some random moves and keep on doing the thing, it actually learns in such a way so that it started to beat any human. It started to play very well with respect to any human. So the objective is to finish the game with the highest score. Game state can be raw pixels. So what is the game state? Game state is going to be the single screen, video screen. You show me the video screen. Depending upon that video screen, agent is going to take the action, whether I need to move left or I need to move right or so on. So just your input raw screen was actually as an image can be used as a state. Action was that, several times all these games, Attari games and all, they are having, maybe you need to go left or right or up or down. So you need to go in this direction, here, here, or here. And reward is going to be at the end of the episode. If you got win, that after the episode, you know that, oh, I won this thing. So all the state and action pair. At this state, you have taken this step. At this step, you have taken this step. At this state, you have taken this step. Keep on doing. If you want, for all that state action, you are going to get a +1 reward, else you are going to get a -1 reward. Yes, any question? Yeah, any question?
Sir, so will this motivate the agent to play the game longer and longer, even though the game could have been finished earlier?
The game will be finished and then he has to restart the next game.
Yes, no, if the reward is like for each state action pair, he will get a +1. So he will
Yes.
try to maximize the number of actions, even though the game could have been finished with less number of actions.
Okay, so those are optimizations that we will see later. This is just a raw example. Okay.
Yes.
So then we need to keep on adding few more things so as to get it as early as possible and so on, to minimize the number of steps and so on. But this is raw, way by which we can see that any problem that can be posed as an RL, what you need to figure out, you need to figure out that what is your objective, what is your state, what is your action, what is your reward. And if that is the case,
Sir,
you can apply RL algorithm. Puchiye.
Sir, there are so many different steps that the agent can take, right, in any game. So how are they storing all the posts? Like the reward is stored, right? So are they storing so many different
Yes.
type of steps?
So right now this problem is being defined as that it's actually discrete action space, which means that only 4 directions your agent can move. So Atari games, they were having a finite state action space, which essentially means that actions are not continuous. You can move in this direction also, but it's not allowed. You can move in this direction also, it's not allowed. You can move in this direction also, it's not allowed. You can move in this direction, it's not allowed. You may have seen those old games in which, the action space was discrete. And then I say that right now they are left, right, up and down, only 4 things. So if it is discrete, it can be the thing. We will be talking about that if your action space is discrete, what type of algorithms will work if your action space is continuous, what different types of algorithms we need to figure out. Okay? Yes. Who was asking? Deepali, Deepti. Can you listen? Yes, no. Network issue?
Yes, sir.
We can.
Okay, okay. Formulation. So what is what's our Markov property says that the future is independent of the past. Future is independent of the past. What does that mean? Mathematically, it means that you all understand this notion that is the conditional probability that given ST, what is the probability that you will be moving into ST plus 1? Given ST, what's the probability that you will be at probability? So you will be moving from ST to ST plus 1 is actually equal to this. So if you give me all the states, all the previous states, and ask me that what's the probability by which I am landing in my TST plus 1, it's same as this, which essentially means that you are not adding any information by giving me more and more state. That's the Markov property we all know, which essentially Markov property says that everything is being encoded in my ST itself. I don't require anything of the previous time. Everything is inside in this. That's your Markov property. So that is Markov property, and the processes which are following that, they are called as the Markovian process. And now the point is that if you have a Markov process, depending upon the state you need to take an action, then it will become Markovian decision process. So Markov process can be, you need not to take any decision. Your previous state is just going to tell you that what's going to be your next state. You need not to take any action. But if you have to take any action that you need to decide what action that you need to take, then Markovian process converts into Markovian decision process. General example is that if you are very small, along with your father, then you are not going to take any decision. And if your father is following Markov processes, then that whole thing actually will be if it follows the Markov property, then that's a Markovian process. You don't have to take any decision. But when you grow, you understand that, okay, I need to take my decision whether I need to take this subject or that subject. So depending upon the state, you decide what action that you need to take. And the important thing is that whatever you know currently, only on that you are depending what to take or what to do next. So you are actually visualizing a Markovian decision process. So it's a decision process, choosing actions, and can actually be defined by these 3, 4, 5 tuples. There are 5 things, and using these 5, we can define a MDP for you. I'm going to explain all of them one by one. Keep on writing about that. S, A, P, R, and gamma. What is S? All possible states. All possible states. Whatever the game, whatever the problem that you wanted to solve, in that all possible states can actually be coming from this S. So for the formulation of a problem as an MDP, all the states that can be possible, they will actually be belonging to this capital S. What is A? All possible actions. Now, if your agent can move left or right, if it's a 1D motion, A can actually be left or right. And if it's a discrete and only +1 and -1, then only 2 actions, left or right. If it is having left, right, top, bottom, there may be 4 actions. If it is continuous, then it is having infinite actions. P is going to be seen as the state transition matrix. At this state, if you take this action, you will be ending up at this state. This is the whole game logic, that at this state, if you take this action, what is going to be your next state? P is going to tell you that what is going to be your next state. P function. P need to be given to us. That can actually be seen as the model of your game. So
Sir,
there
does P also tells us the invalid actions? Like if I take from this state this action, then it's invalid. Does
you
it also
cannot take
state
any
that?
invalid actions because P is going to tell you that what is the valid action. Using
Okay,
using P, you are going to take the action. So P is a function. You need to tell P, hey, ST, okay, and I have taken AT, okay, I am P. I am telling you ST +1. So you cannot take
Yeah.
any
Okay.
okay. Yeah. So what I was saying is that if you know P, if P is known to you, which essentially means that you know the game and how it has been played, that type of model, that type of algorithms are actually called as model full algorithm. If you need to know the P, which is several times not known because of the fact that state action spaces are infinite and too much big. आ रही बात समझ में? ये नहीं. State action बहुत सारे हैं. There are so many states, so many action. For each action, for each state, you may be having so many actions. And if you know the P, then that's a model full algorithm. If you don't know the P, but still wanted to play, let your agent learn. Those are model-less algorithms. So most of the time, we do not have model-full algorithms because knowing P is very difficult. It's just for the sake of completeness, we are telling that P and this, and if it's a very small game like tic-tac-toe or something like that, you can figure out what is P. But in very difficult games, big game, strategies, so many things, it's very difficult to really understand or compute that for each and every state. If I take this action, that one, what's going to be the next state? But most of the time, this P is going to be utilizing some gaming engine. There is a gaming engine. What is the name of that gaming engine? Do you remember? In that book they have given, I forgot the name. Jim. The package name is Jim. By the way, we are not going to do any type of gaming environment creation. You can use, there are several gaming environment created using Jim, but those who are interested in gaming, they can see this engine. It's having certain physics engines are also being there, but Jim is something which is having several different types of games being incorporated for you. You just import it and give it the state, give it the action, it's going to give you the next state. For us, it is done. Right. What is R? R is going to be the reward. We have decided what's going to be the reward. If you at this state, if you have taken this action, what is my reward? We need to figure out that what is the reward. We'll have to decide this. So this is again a function. This gamma is a discount function which is going to be applied over my reward function, and I will come back to it. I will come back to it, that why do we require discounted rewards rather than full rewards. But by the way, just here you see state and action. If you give me, I will give it to P. It is going to give me the next state. I will give it to R. It is going to give me the reward. State transition matrix P can actually be seen as this. What does it mean? Probability of at state S. If you take an action A, you reach to S dash. At state S, if you take an action A, you will reach S dash. What does that mean? That's a notation, by the way. Mathematically, it means given that ST is equal to A, AT is equal to A, ST is equal to S, AT is equal to A, what is the probability by which ST plus 1 is going to be S dash? Several games may be deterministic, several games may be non-deterministic, in which same state, if you take different actions, you are going to be at different states. So it can actually be over, incorporated over here. Any question? कोई question नहीं.
So like इसमें कोई एग्जांपल कि जो मतलब स्टेट और एक्शन ले तो ये हर बार स्टेट जो है चेंज हो.
मैं एग्जांपल देता हूं. आप इस जगह पे हैं, ये एक्शन लिया तो आप यहां पहुंच गए. ट्रू. But there may be several different. So this is like, deterministic thing, that if at this state, if I take this action, I will be ended up over here, which essentially means that the probability is going to be equal to 1. It's a deterministic step. But there may be games in which at this state, If you take action A with the probability this, you will be here. With the probability this, you will be here. With the probability this, you will be here. It is just like maybe a game is like tossing up a coin. So at a particular state, if you have taken some step, it is saying that it's like that you have tossed up a coin, and with a 50% probability, you may be over this state or you may be over this state. If that is the case, that's a non-deterministic framework, and that can also be incorporated inside this. But if it's a deterministic framework, which essentially means that P S dash A will actually be either 0 or 1. 0, which essentially means that it is invalid. 1, which essentially means that it's a valid thing. And it can be in between also, depending upon the dynamics of the game. Prashant, no, yes.
Yes, sir.
Okay. Reward. Immediate reward. What's the immediate reward? Immediate reward is that I take an action. I'm at a state. I take an action. I'll get an immediate reward. Who is going to tell me? Capital R. Capital R, you submit your ST and AT, it is going to tell you what is RT. What is your reward? That's your immediate reward. Can be written as this, straightforward. R ST AT, R ST AT, that's a function. R is a function. Now, important thing about MDPs are that most of the time we are not interested in immediate rewards. We are interested in the optimal behavior, which essentially mean we need to maximize the average, write it down, average discounted cumulative future reward. There are many terms over there. Let me talk about it one by one. Reward, future reward, cumulative, discounted, and average. This E is for expectation. कितने लोगों को expectation का बिल्कुल भी अंदाजा नहीं है? हाथ खड़ा करिए. E expectation का कोई भी अंदाजा नहीं है? कोई नहीं. जल्दी जल्दी. अगर किसी को expectation का कोई भी अंदाजा नहीं है तो हाथ खड़ा करें. है तो very good. और ये होना चाहिए. ऐसी सब बहुत सी चीजें आगे आएंगी. But we do not require too much amount of mathematics, but we require good amount of mathematics and top level understanding. तो पहली बात तो ये कि reward आ गया. दूसरी बात ये कि future reward आ गया. Future reward क्यों चाहिए? We all understand because we wanted to optimize our network in such a way so as to get the best possible future rewards. अभी क्या दे रहे हो? Forget. 10 साल में क्या मिलेगा? बात करो उसकी. That's why I need to see the future reward. Secondly, cumulative, which essentially means that don't tell me that at this step I will get this, this step I will get this, then this, then this, then this, then this, and finally this. You add all of them. That's your future reward. You add all of them, get the average for all the trajectories, for all of my episodes, and that is the cumulative reward. Discounted, I will come back. So let us see this one trajectory. This is a single trajectory for you. I'm starting with some state this. Take an action, 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 and take an action. Got terminated. What is the reward of this trajectory? Summation Ri. R0 plus R1, R2, R3, R4, R5. This is the reward of one trajectory. This is the future reward. Then I have another trajectory. 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 I have so many trajectories. If I do, so if this first thing is this, all these things, if I add, I'm going to get a cumulative future reward. I got a cumulative future reward. Forget about discounted. This is cumulative future reward. Everyone okay? CFR, cumulative future reward summation RI for a trajectory. And forget about this D. What is this expectation? I have so many different trajectories. In fact, I cannot play for all the trajectories, but I take good amount of trajectories and play for them. Huge amount of trajectories I've generated. And for all of them, I compute the cumulative future reward. Find out its average value. I need to train my network to give me the maximized CFR. Now, what is discounted? Before that, is there any question? Koi question? Chinmay Patil, do you have any question?
No, sir.
नो सर, तो फिर अगला क्वेश्चन आप बताओ, ये डिस्काउंटेड कहां से आ गया? बताओ, कुछ भी बोलो. चिन्मय पाटिल, कैन यू लिसन?
Yes, sir.
बताइए. चिन्मय पाटिल. हाँ, कुछ तो बताना पड़ेगा.
सर कुछ नहीं बताऊंगा.
कैसे नहीं बताओगे? बताना तो पड़ेगा ही. प्रॉब्लम क्या है? प्रॉब्लम बताओ मुझे, क्या समझ में नहीं आया?
सर क्यूमुलेटिव फ्यूचर रिवॉर्ड तक तो सब समझ में आ गया था. डिस्काउंटेड कहा
तो देखो
सर.
फिर, ये है चिन्मय पाटिल, ठीक है? तुम किस सब्जेक्ट के स्टूडेंट हो? पहले तो ये बताओ, अपना बैकग्राउंड बताओ.
मैकेनिकल में सर.
मैकेनिकल विच ईयर?
4th ईयर.
4th ईयर मैकेनिकल स्टूडेंट, IIT मंडी. 4th ईयर IIT मंडी मैकेनिकल. अब देखो, आज यही बैठे बैठे तुम्हारा फ्यूचर डिसाइड कर देते हैं, ठीक है? तो तुमको एक गुरु मिल गए, पाई. वो पाई नहीं है, समझे ना? ये पाई वो वाला पाई नहीं है, ये पाई इज अ फंक्शन. इसको अपनी स्टेट बताते जाओगे, ये तुम्हें नेक्स्ट स्टेट. हाँ, सॉरी, कैन यू लिसन? चिन्मय पाटिल.
यस सर.
हाँ चिन्मय मैंने
Yes, sir.
क्या बोला था कि चिन्मय पाटिल ने MS किया, PhD किया और एक इंडस्ट्री ज्वाइन कर लिया. ये तुम्हारी एक ट्रैजेक्टरी है, ठीक है?
Yes, sir.
ऐसी एक ही ट्रेजेक्टरी तो नहीं हो सकती ना। चिन्मय पाटिल ने मान लो इसके बाद क्रिकेट टीम ही ज्वाइन कर लिया, उसके बाद इंडियन टीम ज्वाइन कर लिया, उसके बाद पॉलिटिक्स ज्वाइन कर लिया, उसके बाद वो पीएम ही बन गया। ये भी हो सकता है,
Yes.
हो सकता है, वो बहुत कम प्रोबेबिलिटी से हो सकता है, कोई बात नहीं, लेकिन हो ऐसा सकता है। अगर तुम्हें वैसा पाई मिले तो इसके बाद फिर से तुमने कुछ और किया, इसके बाद फिर से तुमने कुछ और किया। अब ये सारे एपिसोड्स हैं, यू आर नॉट डूइंग एनीथिंग, वी आर जस्ट सिमुलेटिंग दीज एपिसोड्स वन बाय वन। अच्छा, देन आई कंप्यूट क्यूमुलेटिव फ्यूचर रिवॉर्ड, क्यूमुलेटिव फ्यूचर रिवॉर्ड, क्यूमुलेटिव फ्यूचर रिवॉर्ड, क्यूमुलेटिव फ्यूचर रिवॉर्ड, and then add and do the average divided by 4. That's a expected value of, or the average value of cumulative future reward that we need to maximize. कुछ भी करो, ऐसे ऐसे ऐसा पाई सीखो जो तुम्हें इन सारी पॉसिबिलिटीज में उसमें आगे लेके जाए, जिसमें कि यू आर गोइंग टू गेट द मैक्सिमम बेनिफिट इन टर्म्स ऑफ रिवॉर्ड। यहां तक ओके है?
Yes, sir.
Now the point is that it has to be discounted. Why? Because if somebody wanted to come and tell you, hey, चिन्मय पटेल तुम मेरे साथ आओ, एक पाई है तुमसे कह रहा है मेरे साथ आओ, 25 साल बाद तुम्हारी जो सैलरी होगी वो 1 करोड़ रुपए होगी। ध्यान से सुनो ये बात आगे समझ में, तुम जाओगे उसके पास?
हाँ।
ठीक है, 25 करोड़, लेकिन उसने बीच का नहीं बताया कुछ। 25 साल तक कुछ भी पैसा नहीं मिला तो
दिक्कत है फिर तो।
then because we are talking about future is not perfect and predictable. When things are not predictable, we are not going to take the rewards as full as possible. We started to discount it. How you can going to discount? It is saying that ये 1 करोड़, I don't see this as 1 करोड़. First you tell me 10, आज से after 1 month, पहले month की सैलरी बताओगे क्या है? Tell me the first month salary. He's saying your first month salary is 10,000 rupees. Your second month salary is also 10,000 rupees. Your 25th month salary is 20,000 rupees. Your 30-month salary is 30,000 rupees, and so on. Now can you think that you wanted to go in that direction?
No, sir.
Your first month salary is 10,000.
No, sir.
Then what happened? You wanted to give high importance to the reward which is near in future, and low importance to the rewards which are very far, because they are uncertain, because corona comes, because something comes, because so many uncertainty factors are there, because of which let me tell you what we do. Because of which, if this is R0, I will say I am fine with this R0, but this gamma with this R1, I am saying it is going to be gamma times R1. This is going to be gamma square times R2, gamma cube times R3, and so on. That is discountation that we are doing. That is what we are saying, that highest importance to the thing which is near in future. If you are very far, less and less and less important. That is discounted. So now we understand that rewards, then future reward, then cumulative, then discounted future reward, the expected value need to be maximized. Chinmay Patil, is that okay?
Yes, sir.
Now, how can we utilize an MDP to obtain episodes? It's very simple. We have talked about it. MDP in execution, that at any time t equal to 0, your environment may sample randomly an initial state. So any game, there can be one initial state, there can be several initial states. Out of that several states, you randomly choose some initial state that is going to be your S0. From t equal to 0 until you terminate, agent keep on selecting an action AT. How? It is written how. Now we know that how it is going to select something. That's a pi, which is going to tell you. But there is some way. Assume right now some random policy is there that need to be learned properly, but it is there. So given any state, you want someone who can tell you that what the action that you need to take, that is AT. But that policy, our requirement from that policy is that even if you are random, if you are not random, good, bad, how we are going to decide if you are maximizing my expected value of the DCFRs. Depending upon the state ST, policy is going to tell you that what action that you need to take. And environment is going to tell you that at ST and AT, at ST, if you take AT, I'm going to give you this reward. You need not to do anything. Just environment is going to give you the reward. And it's also going to give you that what's your next state. Your only piece of computation that you need to do is that how to get the next, how to get the action at a state. And that is the decision that you need to make. And you need to make that decision as optimally as possible so that it can maximize the expected value of my DCFRs. And again, the same things are being written over here, that your this and this is the state matrix, this is the reward matrix, and they are this. Okay, they are this. By the way, this gamma of discountation is always between 0 and 1. If it is 1, all the rewards are being treated equally. If it is 0, I'm only looking the immediate reward, and if it is anything in between that, we are looking the spectrum of that. So this is a simple diagram in which S, you are going to S dash. This may be your Tth state, this may be your T plus 1th state. Your probability matrix or the state matrix is going to tell you that what's going to be your next state, and reward function is going to tell you that what's going to be your reward. But how to take an action? This is the policy function for you. Understand MDP. MDP is having 5 tuples S, A, P, R, gamma. You are not learning any of them. Everything has to be known or maybe incorporated or embedded in some gaming engine. We are not bothered about that. Our point is that if I give you a state, how to take an action? The policy is just a mapping of a state to an action. You give me a state, I'm going to give you an action. A state, you just tell me the state, I'm going to give you the action. This is our state to our action. So it takes a state from some state space and map it into some action. It can be deterministic, it can be stochastic. What does that mean? It means that it is not the case that at any state I deterministically choose this action every time. If it is deterministic, which means that at ST state, policy will tell you need to take this action. But it may be the case that at state ST, policy may instead of giving you an index of some action, it is going to give me a probability distribution. That at this state, as you go to your father and say that, Papa, can I go and do this, this? He will say, if you do this, then this is the pros and cons. If you do this, this is the pros and cons. If you do this, this is the pros and cons, and so on. So policy may be stochastic, which is essentially going to give you a probability distribution over all the possible actions. So it is not going to tell you that take this action. I am telling you instead of that at this state, you can take A1 action with this probability, A2 action with this probability, A3 action with this probability, A4 action with this probability. That's why it's a stochastic and it can be deterministic. By the way, what it is? That state S, given state ST, what is going to be the AT? This is telling you that the probability of choosing an action AT given that you are at ST. This can be 1 if it is deterministic, and for all the actions it will be 0 for that case. It can be some value between 0 to 1, and instead of 0 for the remaining state, it will be some non-zero value for all the states, and it actually be seen as a probability density function. यहाँ पे कोई क्वेश्चन हो तो पूछ लो. Any question?
Sir, for all RL algorithm is the DCFR same, like
थोड़ा जोर से बोलो प्रियांशु, पास में आके.
हर RL algorithm के लिए DCFR ही होगा क्या? मतलब वो रिवॉल्ट जिसे हम लोग मेजर करेंगे, क्योंकि मतलब लाइक इन अ मिनीमैक्स गेम अगर एक मतलब कुछ लेने पे क्या कोई एक मतलब एक्शन है, जैसे कि वो क्रिकेट वाला एग्जांपल था, तो एक बंदा क्रिकेट ले रहा है, तो उसके बाद हो सकता है वो बहुत गंदा फ्लॉप हो जाए, या हो सकता है वो स्टार बन जाए. तो उस केस में मतलब उसका जो एवरेज होगा वो तो मतलब समथिंग अराउंड मिडिल हो जाएगा, बट हो सकता है कि उससे बहुत ज्यादा बड़ा स्टार बन जाए. तो वो एक हाइपर पैरामीटर की तरह ट्रीट होगा DCFR, या फिर वो फिक्स्ड है कि DCFR ही हमेशा RL में यूज होगा?
तुम DCFR में गामा की बात कर रहे हो कि वो हमेशा
नहीं, DCFR मतलब एवरेज लेंगे हर रिवॉर्ड का, या फिर हो सकता है कि कभी हम लोग सिर्फ जो मैक्सिमम आ सकता है उससे वो ले?
नहीं, मैक्सिमम से कभी भी काम नहीं चलेगा, क्योंकि दुनिया में मैक्सिमा होते ही नहीं है. मैक्सिमा इज लाइक दैट यू आर अज्यूमिंग द बेस्ट केसेस.
यस सर.
ठीक है ना? तो बेस्ट केस एनालिसिस तो कभी करते ही नहीं है. वर्स्ट केस एनालिसिस भी अच्छी नहीं रहती, बट इन द केस ऑफ एल्गोरिथम्स वी वांटेड टू मेक श्योर कि वर्स्ट केस एनालिसिस में भी इट इज गुड. फॉर द केस ऑफ रैंडम सैंपलिंग, बिकॉज you are playing episodes and these episodes are randomly generated.
Yes sir.
So that is why you need to talk about expectation, because if there is anything which is random,
yes
ये सब रैंडम काम जब होता है रैंडम प्रोसेसेस के थ्रू, तो किसी भी रैंडम प्रोसेस को देखने के लिए यू नीड एक्सपेक्टेड वैल्यू, वरना बात नहीं होगी. जैसे आपने बोला कि हो सकता है कि विराट कोहली क्रिकेट नहीं खेलता, गाना नहीं फिल्मों में काम करता, तो भी वो अच्छा खिलाड़ी, मतलब तो भी वो एक अच्छा ये बन सकता था बैट्समैन, सॉरी अच्छा फिल्म स्टार भी बन सकता था. वैसे ही विराट कोहली अच्छा क्रिकेटर भी बन सकता है. बट देन यू प्ले सो मेनी ट्रेजेक्टरीज, आउट ऑफ दैट 80% में विराट इज परफॉर्मिंग वेरी गुड एज अ बैट्समैन, 20% में समथिंग एल्स. सो इट्स मोर that you need to push your parameters in such a way so that Virat Kohli keep on getting the advice that he need to become a batsman. If it is 50-50, example किसका लेना है 50-50, I don't know any good cricketer who is a good film star.
सर अगर हम लोग टिक टैक टो का एग्जांपल लें जैसे कि,
हाँ
तो मतलब मैं एक क्रॉस डाल रहा हूँ कहीं पे, लेकिन उससे ये प्रोबेबिलिटी ज्यादा हो रही है, मतलब 2 बार ऐसा हो रहा है कि वो बंदा जीत रहा है,
हम्म
लेकिन एक बार ऐसा हो रहा है कि जिसमें उसके पास वो पक्का हार जाएगा।
हाँ
2 बार जीतने की मतलब वो हो सकता है कि जीत जाए, लेकिन एक बार ऐसा है कि उसमें पक्का हार जाएगा,
हम्म
और एक दूसरा है जिससे कि टाई हो जाएगा गेम।
हम्म
तो फिर मतलब DCFR से तो मतलब वो टाई वाले को ज्यादा वो मिलेगी ना सर, तो उस सेंस
देखो
में
ये अभी जो आप बात कर रहे हैं, आप बहुत अंदर जाके बात कर रहे हैं, और अब आप स्ट्रेटेजी के अंदर हाउ मच रिस्क यू कैन अफोर्ड, दैट्स वेरी हाई लेवल कॉन्सेप्ट रिस्क। आप समझते हैं बात?
यस सर।
पहले खेलना तो सीखो, उसके बाद जाके, अभी तो खेलना ही नहीं आता, तो फर्स्ट वी नीड टू अंडरस्टैंड हाउ टू प्ले device and strategy, and then that is also a part of a strategy, by the way, how much risk that you can take. So there are algorithms which will be developing one by one over that to figure out that.
ओके सर।
हाँ ठीक है, but average case analysis के अंतर्गत it is going to make sure that whatever you do, you are going to choose that actions which are going to by far going to give you very good results. Okay,
ओके सर।
now what is the goal of an MDP? मेरे गोल क्या है MDP का? दूर से पढ़ के देखता हूं। The objective of MDP is to find an optimal policy pi-astic. Understand, there can be policy 1, policy 2, policy 3, policy 4. This is a whole policy space in which I am having infinite amount of policies. Policy तुम्हारे दोस्त हैं। उस दिन मैंने लिया था किसी का एग्जाम्पल. Now I take the example of Balkar. Balkar is having one good friend right now who is his policy. बलकार को कुछ भी करना होता है, वो पहले उस बंदे से पूछता है कि मैं क्या करूं. तो इन द केस ऑफ बलकार, दिस देयर इज अ स्पेस ऑफ पॉलिसी. देयर इज पॉलिसी 1, पॉलिसी 2, पॉलिसी 3, पॉलिसी 4, पॉलिसी 5, पॉलिसी 6. बलकार ने पॉलिसी 1 को चुना, पूछा ये बताओ मैं क्या करूं. उसके बाद बलकार ने कुछ दिनों तक उसको फॉलो किया, फिर उसे मजा नहीं आया, वो ठीक से नहीं बता रहा था, तो पॉलिसी 2 पे चला गया, फिर पॉलिसी 5 पे आ गया, फिर पॉलिसी 8 पे आ गया. उसी में एक ऐसी पॉलिसी है जिसका नाम है pi-astic. This is the optimal policy. What is the optimal policy? That given Balkar, that policy that can maximize Balkar's DCFRs. तो हमारा ऑब्जेक्टिव है ऑप्टिमल पॉलिसी को लर्न करना, जो कि DCFRs को maximize करे. That's our optimal policy. So out of all the possible policies, pi-astic is the one which is going to maximize my DCFRs. The actual rewards or returns are always in the form of DCFRs. Discounted, जो कि मैंने आपको बता दिया था, can be written as this. ये फॉर्मूले में k equal to 0 रखना है, 1 रखना है. Don't confuse much, because some persons may start it from k equal to 1 to infinity, and some may start from 0 to infinity. So don't worry, it depends that if you are taking 0 as your initial, somebody is taking 1 as initial, and so on. Don't want to bother you much about it, but your gamma is strictly between 0 and 1, comma close to 0 myopic, close to 1 far sighted.
Sir, I have a question.
पूछिए.
Sir, why we are giving less importance to the rewards which we get at the initial state? If you look to the formulation above, can you go?
Initial states we are giving more importance. If you are near in future, more importance. Far in future, less importance.
Okay, so we are giving why exponential, power of gamma only.
तो एक्सपोनेंशिएशन से क्या होगा कि अगर 0.9 है वैल्यू, तो पहले R0 आएगा, फिर 0.9 टाइम्स R1 आएगा, फिर 0.81 टाइम्स R2 आएगा, फिर 0.729 टाइम्स R3 आएगा, एंड सो ऑन.
But rewards is the total sum only, so then why we need to do this?
अच्छा ये है बात. तो लो आ गया. वैसे सारी बातें मैंने बता दी हैं, लेकिन अब तुमने पूछ लिया है तो लिखा हुआ है। किसने पूछा था, मैं नाम नहीं देख पाया, सॉरी।
सर कोमल को।
कोमल, कोमल देखो, फ्यूचर इज अनसर्टेन। अगर एग्रीड नहीं हो तो तुरंत बोल देना नो सर, फ्यूचर इज अनसर्टेन। मैं आई एम जस्ट टेलिंग दैट व्हाई वी आर डिस्काउंटिंग, हालांकि आई हैव एनीवेज टोल्ड यू ऑल दिस स्टफ। फ्यूचर इज अनसर्टेन and we care about it. How? So if I invest 1k rupees today, then how do I need to care that about my returns after 1 year, 5 year, 10 years and so on? तो अपने रिटर्न्स को किस तरह, कितना केयर करते हो आफ्टर 1 ईयर के, 5 ईयर के, 10 ईयर के और 50 ईयर्स के और 100 ईयर्स के और 500 ईयर्स के? तो आपने बोला कि my gamma is 0.9, so maybe 1 ईयर को मैं 0.9 दूं, मतलब 1 ईयर को मैं फुल दूं, 5 ईयर को 0.9 दूं, इसको कुछ और दूं, इसको कुछ और दूं, इसको कुछ और दूं, बिकॉज माय फ्यूचर इज uncertain. So don't give too much amount of weightage to your future. Second point, since we are predicting using an inaccurate model, understand यार, तुमको दुनिया पता नहीं है कैसे चलती है, these models are inaccurate. अभी मॉडल बना रहे हो, पाई को पाई you are learning, but your pi is not the perfect pi. You are not getting Ramkrishna Paramhans. If you have got the Ramkrishna Paramhans, okay, but that is pi-astic optimal policy, and your pi 0 is a very poor policy, which is maybe a random policy, and from this you keep on moving here and here and here, and then you try to move over here. That is why don't rely too much on your predictions. Mathematically it's a convenient thing, and avoid infinite returns in the cyclic Markov processes, because if you have a cyclic thing, then you keep on moving in this and you get infinite value. गामा लगा दोगे कभी भी infinite नहीं जाएगा, it becomes a geometric series और वो converge कर जाती है, convergent series होती है. कोमल, yes no, ठीक है?
Yes sir, yes sir, got it.
मैं थोड़ा मैथमेटिकल जवाब दे दिया, हालांकि इसको हाई लेवल पे मैंने पहले बता दिया था. Yes, so with this we will be stopping today over here, and in our next lecture I will be going to take this example of grid world, in which I'm having a grid. This is a game. I'm having a grid. This is a terminal state. This is a terminal state, and you need to train an agent which will start from here or here or here or here or here, wherever it starts. It needs to understand and learn a policy by which it can very fast, with minimum amount of steps, reach from here to the any terminal state. If it is here, it can go here. If it is here, it will come here. If it is here, it will come here. If it is here, this, or it may come over here, because it's taking again 2 steps. So this example, very simple example, we will not be using this example to solve any RL problem, because it's a very simple example. We need to understand how to formulate this question or problem as an MDP and solve it using RL type of framework in our next lecture. Yes, so our timing is almost fixed. We are going to share all the material, previous lecture notes, previous lectures, all these lecture notes. Today you are going to get all that stuff, and please start reading. If you have any questions, next lecture come back to me. Thank you.
Sir,
Sir.
today's lecture will also be shared. Today's
Second
lecture.
lecture, क्या कह रही हैं, फिर से बोलिए.
सर मेरा इंटरनेट डिस्कनेक्ट हो गया था, तो आज के कुछ मिनट्स मिस
सारे
हो गए,
lecture
तो
आपको मिल जाएंगे, पहली बात. और दूसरी बात ये कि पहले से ही पढ़े हुए हैं. आज आपको पूरा आरएल का पुराना मैं लिंक ही शेयर कर दूंगा. सब कुछ ऐसे ही मैंने पढ़ा रखा है, कोई नई चीज मैं पढ़ा ही नहीं सकता, क्योंकि ये सब कुछ तो वही है. So we will share it today itself. Any other one? Anyone else?
Okay. Sir, yes sir. Sir, can I ask one question?
पूछिए.
Sir, action, we were assuming actions are only discrete. So when we are copying some human in artificial intelligence using reinforcement learning, so then we can see in already written already done
सुनो
the
मेरी बात,
project.
मुझे समझ नहीं आ रहा है बहुत, तुम थोड़ा तेज बोलो पास में आके माइक के।
सर हम ये कह रहे हैं कि अगर ह्यूमन को डिक्टो कॉपी करना है तो एक्शन को मतलब एक उसमें कंटिन्यूस फ्रेमवर्क एक्शन, सारे एक्शन जो होंगे कंटिन्यूस लेके देन वी कैन, बिकॉज यहाँ पे हमें कोई भी एक्शन का ऐसा नहीं है कि जरूरी नहीं है कि डिस्क्रीट ही होना चाहिए, तो कंटिन्यूस भी होगा तो भी देन इट विल वर्क। सो सर ऐसा कुछ मॉडल तैयार हुआ है, आई मीन कंटिन्यूस एक्शन भी where we can use.
बिल्कुल भाई, अभी पढ़ाएंगे, क्यों परेशान हो? कंटिन्यूअस के बिना काम चलेगा तुम्हारा? सारे एक्शन डिस्क्रीट थोड़े होंगे हर गेम के, तो कंटिन्यूअस को पढ़ाने के लिए पहले डिस्क्रीट का तो जान लो, सिंपल वाले का, फिर कंटिन्यूअस पे आएंगे। यही पूछ रहे हो ना?
Yes sir.
तो कंटिन्यूअस आएगा, डोंट वरी। एनीवन एल्स?
सर ये गामा पैरामीटर है या खुद फिक्स मतलब
गामा फिक्स्ड है, ऑलमोस्ट 0.9 हर कोई यूज करता है, थोड़ा बहुत ऊपर कर लोगे तो कुछ फर्क नहीं
हाँ
पड़ेगा।
सर, वो ये 0.9 और 0 का मतलब क्या होता है, मतलब समझा नहीं।
0.9 का मतलब ये है ना कि पहले वाले जैसे R0 प्लस R1 में गामा डालते हैं, R2 में गामा स्क्वायर डालते हैं, R3 में गामा क्यूब डालते हैं, ठीक है? तो
अच्छा, मतलब इम्पोर्टेंस कम दे रहे, ठीक है।
हाँ, दैट्स अ ज्योमेट्रिक सीरीज ना, सो दैट इज द थिंग। तो गामा की वैल्यू अगर 0.9 है तो फर्स्ट टाइम 0.9 आएगा, सेकंड टाइम 0.8 आएगा, फिर 0.7 आएगा, 0.6 आएगा, तो ऐसे डिक्रीज होता जाएगा लंबे समय के बाद। ठीक है प्रशांत?
यस सर।
और किसी को कुछ पूछना है? ठीक है, देन थैंक यू वेरी मच, बाय।